Now, layer 2 technology is pretty straightforward, and again, like I said in the earlier portion of the class, it's something that we have a tendency to take for granted. It's primarily a plug-and-play style technology, depending on the particular type of devices that we work with. So what we're going to do is we're going to take first a cursory look at how things are going to be interconnected in our particular pieces of equipment regarding our labs and our topology, and we want to start taking this and building it into a solution that we're going to be able to use. Now, what I have first of all here is I have my equipment. Now, when I work on labs, all right, I generally try to come up with the same configuration that I use on all of my devices that's a baseline, and it's going to follow the same baseline configuration that Cisco is going to recommend. Now, I do this in Notepad. I do this in Notepad because it facilitates the configuration. And let's see, I'm going to change my font size to something that you guys can see a little bit better. Still a little bit bigger than that. Let's go up to something like 24. So what I do is I always, from scratch, start my equipment with the basic configurations, which is going to be the EN, the config T, and then from there what I do is I do no IP domain lookup. Now the reason that I do that is that I have a tendency to fat finger. I always make a lot of typographical mistakes, and in doing that, when you do it at the command line, the system is going to try to query a DNS server. If I type no IP domain lookup in the console, then it's going to stop that behavior, and I'm not going to get hung up by virtue of the fact that I've made typographical mistakes. Inside the context of the lab, you're going to have the same issue with regard to how Cisco is going to do it both in the configuration and in the troubleshooting section. This command will probably be already on the router itself to start with. So once that's done, then I need to go into my line console 0, and I'm going to do my basic configurations. Now, I don't like to do security configurations on devices when I'm labbing. It's just something that I don't really want to work with, but there are commands that I want to take care of, like no synchronization or no sync. Now, by doing that, what I'm basically doing is I'm setting the system up so that such I'm typing, it's not going to interrupt the messages or my console that I'm actually typing on with console messages. And then the other thing is that it's a pain in the butt when our routers just all of a sudden kick us out, as well as switches. So what I'm going to do is I'm going to say no exec dash timeout. Now you could also come in here and say exec timeout 0 space 0. Now the idea here is that when we're setting this up, you can go ahead and get into your racks if you want. I'm just walking you through some of the basic setups, and I was going to recommend, Avery said he got back a little bit late. He's basically asking us to whether or not you guys can get into the gear. When you get into the gear, if you choose to follow with me, that's perfectly fine, not a problem at all. But what I want you to do is just get into your catalyst switches, Cat 1, Cat 2, Cat 3, and Cat 4, and leave your routers alone because I've got Jake who's currently trying to shake out the rest of the configs in pods 109 down to 112. So, you know, again, if you want to, jump right in. Now, the other configuration obviously is going to be our host name. Now, our host name is going to vary, but for the purposes of our conversations at layer 2, predominantly we're going to rely on the cat config. Now, any other configuration I would normally do after the fact, but there is one that I want to make certain that we add, and that is the fact that I want to have no services timestamps enabled. Now, I mentioned earlier, I'm a big believer in real estate. So in other words, when the messages come up, I want to see all of the messages. I don't want them to wrap around. I don't care what time it is right now. Now later on, we will institute timing because we're going to see how often messages are going to be generated. But when we look at everything from the point of view of this type of configuration, I'm not going to really concern myself with it. Now, once that's done, all I'm going to do is I'm going to leave this as a configuration, and then I'll enter in any differences manually. So I'm going to copy it, and then all I'm going to do is I'm going to go to my equipment. Now I'm on Cat 1, and what I'll do just to make my life easier is I'm going to say Shift P, and let's see, no sync, didn't take, and no services. It should be no service timestamp. So let me go ahead and correct my template. So it's no services, and it should be, oh, I typed it wrong, no sync. So now let me grab it and do the same thing. So Command copy. So just to make sure, I'll just paste it in here. Everything should go through to include the host name. Still didn't like the sync. Line console 0. Logging synchronous. All right. So just to make things squared away here, we'll see what happens. I'll do V. And it's not liking it. It's not liking no. That's why. Duh. Terry needs to learn to spell. Terry's been pretty nervous since he got up this morning, so you guys are just going to have to deal with Terry's foolhardiness. Copy. So now, this is going to be Cat 2. We'll cut over to Cat 3, do the same thing. Did I not grab it all? I promise using Notepad's supposed to help. Nope, I didn't. I screwed it up. If you get it right. Command V. There we go. Still doesn't like it. So we'll go ahead and we'll just do it manually. Line, console, 0, logging, synchronous. Excuse me. Exit. Cat 3. EN, config T. No IP domain. Look up. Line, console, 0, logging, synchronous. No exec. Timeout. Like I said, you could also say exec dash timeout 0, 0 if you so chose. Now, the other thing was I want to turn timestamps off. No service timestamps. So we've got the basics in here except for the host name. So host name Cat 4. So now we've got everything into the system that's configured. Now, and it says log instead of no. Yeah. Is that what I did? Yeah, we'll figure it out. We got around it. I've yet to be smart enough to lock myself out completely. So I just grabbed a marker. Now, a lot of people don't like me drawing on the console. All right. I like drawing on the console because I hate having to toggle between the console and a whiteboard. So if you guys have a problem with it, just let me know and I'll adjust the presentation accordingly. But until I hear otherwise, I'm going to draw on the console for the next 5 days because it's just so much easier for us to be able to do things. Now, what I want to do is I want to illustrate the fact that we have Cat 1 connected to Cat 2, connected to Cat 3, connected to Cat 4. These are our catalyst switches. Now, the first thing that we want to understand is that when we start doing these connections, how do we determine what interfaces are connected to what devices? What's the fastest tool that I have in my inventory to allow me to be able to identify information associated with links and neighbors? Correct. Williams got us with show CDP neighbor. Now, show CDP neighbor is a protocol that's going to be running by default in most instances. Sometimes it may be turned off, and we're going to be able to enable it and disable it both at the console and at the interface level. Just depends on how granular we want to be. Now, it's through the use of CDP that we are going to be able to exchange information, but the thing that we need to recognize here is that CDP is Cisco proprietary. I mean, that's what the C stands for. So it's Cisco proprietary. I'll move my big old head over here. All right, now, Cisco uses this protocol to be able to do exactly what we were talking about. It's good and it's extremely handy to be able to discover our neighbors. In fact, it's so handy, many of the vendors got together and decided they wanted to have a solution, but they wanted to get rid of the Cisco in the name. So what they ended up doing is they created another protocol called LLDP, which is IETF compliant. In fact, it's a standards body solution. And LLDP, depending on whose books you read, stands for Link Local Discovery Protocol, or Logical Link Discovery Protocol. Link Local is the one that I've always known and read, and that's the one that I'm going to drive forward with. So it's still going to be a Layer 2 discovery protocol. Now, what we're going to find out is that CDP does a lot more for us than just expose us to the ability to be able to exchange information between our neighbors. Now, we also have to realize as CCIE, Cisco may call upon us to be able to do manipulations to our CDP protocol that we're going to be running. I mean, it is a protocol. That's what the P is in the name, Cisco Discovery Protocol. We use CDP for a lot of reasons and a lot of purposes. We can use it in the form of being able to ensure that we have voice communications, because what we want to do is we want to communicate critical pieces of information to Ethernet phones that may be connected to particular interfaces. We're also going to find it the fact that we have a routing protocol that is built around it. Anybody know what that routing protocol is? It's not by itself a routing protocol. CDP is not a routing protocol, but there's a routing protocol that's actually built all the way around it. Yes, William got it correct. ODR. That's on-demand routing. Now, on-demand routing is a really funky critter, and it's not in our blueprint anymore. It used to be in the version 3 for the longest time, mentioned passing in version 4, and then gone the way to the dodo in version 5. But it's still a pretty popular and commonly used tool in extremely small environments. On-demand routing utilizes CDP to exchange key pieces of critical information between spokes and the hub that we're doing our configuration on. Now, the problem that you need to understand, or the situation, is the moment we enable a dynamic routing protocol on the hub, ODR is going to turn itself off. We can run ODR on a spoke simultaneously with another routing protocol, but again, I mean, why would we normally find ourselves in a position to do that? So we're not really going to explore the concepts of ODR, but I just definitely wanted to play to the point that Pablo is mentioning, and that is the fact that it's integral to routing. And it's integral to routing in the terms of the actual ODR routing protocol itself. So we've got two options that we want to be able to look at here that we need to realize what's going on. First of all is a Cisco proprietary solution. Cisco proprietary solutions are typically on by default. So what we'll do is let's cut over to the equipment, and on SW1 or Cat1, I'll go between the two terms, SW1 for switch 1 or Catalyst 1. I'm trying to make everything uniform, so I will try to stick to Catalyst, but every once in a while I know I will bounce back and forth. Now what we want to do is I'm going to type show CDP neighbor, the command that we said that we would use. And let's see what it tells us that we're connected to. Now, temporarily, I'm going to take these Catalyst configurations, these drawings off, but we will bring them back. And we want to look at this output. Well, the output that's being communicated to us is going to tell us about our neighbors. Notice we are connected to Cat 4, we're connected to Cat 2. Notice we have connections to Cat 3. Now, when we look at how this is implemented, we know that we're on Cat 1 here, and it's going to tell us how our interfaces are actually interconnected. So just for a brief period of time, I want to bring that drawing back because I want to draw some of these connections in. So notice we see here that we're connected to Cat 4 via interface 19 and 20, but it's 19 and 20 on both ends of the link. So if I come down here, I have two connections, FAO0, 19 and 20, 19 and 20. Now we know that we're connected to each according to this output. But there's also some additional information that we see here. I'm going to erase the CDP here just very shortly, and we'll put it back. But what I want you to see here is notice that we have this value here called a hold time. Now, is that value with the hold time associated with the switch, or is it associated with CDP? We're going to discover it's associated with CDP, and we also see some critical information that's being communicated. Not just the interfaces with which we share a link, but we're also seeing information relevant to the device that's constantly or physically attached to that particular end. Now, as William's saying, this hold down time is part of our table because this is a refreshing protocol. It's a constantly running layer 2 control plane construct that's running between our devices. And what I want to show you is we can come in here and type show CDP with no neighbor configuration, and it's going to give us the relevant information. We're going to see that we're going to send a hello packet out every 60 seconds. We have a hold down value of 180 seconds. That's what this is indicative of. So of the 180 seconds, this is going to be a constantly changing numeric value that we're going to see as a result of the output of the show CDP neighbor command. Now, when we're looking at this, also keep in mind, by default, Cisco is going to support the version 2 of its own protocol. Let's see here. William's got something. He's giving me some information. Show CDP, CDP global, CDP configuration, sending 60. Okay, he's basically reiterating what I have here. So as we look at this, we also can see some other components that's really significant for us. So what I'm going to do is I'm going to type show CDP, and let's use the context sensitive help. And what we're going to see here is we have the capability, let me grab an eraser. We have the capability of doing entries, we can do interfaces, we can do it based on neighbors, we can look at TLVs, which stand for type length values, and we're also going to be operating to where we can see traffic statistics. Don't get CDP and VTP confused, Pablo. Pablo's asking if we can be transparent. No, we're either going to be able to turn CDP on or we're going to be able to turn CDP off. There is no transparent operation where we're just going to ignore it and pass it through. So it's not like VTP. VTP has to do with VLAN propagation and management. It has the idea, oh, let's see, VTP domain version duplex. See, can you be transparent? Okay, Pablo, reiterate your question then, I'm sorry. Oh, transparent. You want me to get out of the screen. You want me to get my big old body out of the way. I apologize. I didn't realize what side of the screen I was on. Yes. So I'll take myself out of the equation right now. Nothing that I'm really adding other than color and an object that's very difficult to see through. So as we look at this, what I want to do is I'm going to pick an interface. Well, we said we have Fast Ethernet 019 is one of the interfaces that we have, but what I'm going to have to do is I'm going to have to type interface, Fast Ethernet 019, and now I'm going to be able to hit enter, and this is going to give me information associated with my individual link. Notice it's telling me how I'm operating. I'm using Ethernet. That's what all this translates to, ARP-A or ARPA. Now also when we go through, there are a number of other things that we can do. So for instance, I can type show, CDP, neighbors, and now I get a whole plethora of information, but one of my favorites right here is detail. Now if I enter detail here, this is going to give me some pretty interesting information. Let me go ahead and just take this off. I'll erase this. And look at what we've got here. I mean, we have a ton of information. The information that we have is going to be related to what native VLAN we're running, how we're operating. We're running in full duplex operation. Any management interfaces that we may have set up in the system. Any of the protocol values that we're going to be running associated with CDP itself. We're also going to find, if I scroll down here, I'm going to learn detailed information about my individual neighbors on a link-by-link basis. Notice, Cat4, that's the switch that we were talking about. It's telling me it's running IGMP, Internet Gateway Management Protocol. It tells me what my hold down time intervals. It tells me the port information that we saw in that one configuration. But even more to that, I know not only what type of device I'm connected to, I know what type of iOS it's running. And as we go down, we're going to find additional pieces of information for each of the individual interfaces that we have connected to a particular neighbor. So I'm going to go ahead and end that. Now there's not a whole lot to this with regard to operation. We can go in and we can change and adjust timers. All we have to do is go to the idea of config T, and when we do CDP, we have the capability of affecting how we're advertising it. We can affect that hold down timer. We can turn on, enable it, or disable it. We can even come in here and specify the rate at which we're going to send those hello messages, and we can exchange specific types of type link values. Now what we're going to learn in our conversations is TLVs are exceedingly important to us in routing and switching, because it's through the use of TLVs that we have the capability of having packets that have variable payloads. Now the ability to have a variable payload can extend from everything from being able to communicate extra information associated with IPv4, or in many instances through the use of TLV we get the capability of supporting IPv6, or the ability to have agnostic capability, payload agnostic enhancements to our routing protocol, so that we don't care what information we're exchanging information about. We're just simply going to put it out in the same format, and we're going to use this idea of TLVs to be able to telegraph to our neighbor what it is we're going to be communicating. We're going to see that in the use in most of our IPv6 routing protocols, EIGRP and OSPF. We're also going to see it in the confines of MPLS, because MPLS is probably going to be one of the most useful payload agnostic protocols that we have available to us in our arsenal. Now that's a lot about CDP, and like I said, we can use CDP run to turn it on. We can do the no form to turn it off, no CDP run. And in addition to that, I could go to an individual interface, FAO19 for instance, and I can say CDP enable to enable it on the interface if it was disabled globally, or I could execute the command here to say no CDP enable. Do show run interface FAO19, and what we're going to see here is this is appearing in our context because it's a non-default config. Now another thing that I want to show here, now that if I come in here and say do show CDP neighbors, and I want to look specifically for information associated with Cat4. Include Cat4. Notice I don't have anything here. Let's see what I've got. It's all case. Sorry, Cat4. There we go. Now I thought we turned it off on 19. Well, we did, but the problem is the idea is that now on 19 we still have this timer. This timer has to expire. So we're going to see this timer gets lower and lower and lower, counting down the seconds until such time that it immediately does what I call cookout. It's going to drop off of our radar. It's no longer going to be a point. But this is 180 seconds. So 3 minutes before this information goes through. So keep that in mind. Now, if I wanted to be able to take a look at this, another thing I want to do while we're waiting for this to actually remove itself is I want to do another command. I'm going to say end, and I'm going to say show run interface FAO19 so we can see that output. Another command that I can enter here is show run all, interface. I've been in NXOS too long. FAO19 all, show run all pipe. Nope, won't be able to do it. So it'll be pipe section. We'll just do it all run. So show run all. Now what I'm doing is I'm looking at all the commands that would specifically make certain that all of this information, all the configuration on this router. So let's go down to 19. So we've got VLAN 1, 6, should have began it at it. 18, 19. So this is the interface in question. Notice all of this information that's actually already configured on this particular device. We have everything from what our actual access VLAN is, what our mode for negotiation, is it on or is it off, what type of values are we running with regard to some of our security procedures that we're going to see. And the whole goal here is the fact that once this is done, we're going to see things associated with not only our CDP, but notice here the fixed values for our CDB TLVs. They're focused specifically on server location at this point to include priority and cost that's been assigned to our given interfaces. So we can see that there's a lot of information that's ordinarily hidden from us. And show CDP neighbors. Notice we only have the one entry now for 4 because it's not in the table, because we've actually removed it. Now another option or another thing that I could have done is I could have changed the timers. So if I come in here and said config T and I said CDP, one of my options is I have the capability of altering that hold down timer. I could have changed this particular value. Another option that I could have done was to be clear CDP, and it's going to allow me to focus on clearing my tables. And if I'd pressed enter, that's going to immediately clear all that data out. So CDP neighbors, and all we would have to do is wait for the hello messages to begin being exchanged between these interfaces. Before I forget, I want to go back over to config T, interface FAO19, and say CDP enable. Show run interface FAO19. Do. If you guys don't know, in NXOS, you do not have to do the do command. And the no command never works on any OS for that. And now it's removed. So looking at what we've got here, I mean, we've talked about using CDP, but what happens if I want to use something like LLDP? Now notice inside the confines of LLDP, we have very similar values. We have a hold down time, we have the timers, we have the capability of enabling it or disabling it. We also have, in this particular version of the iOS, which is 66, I have the ability to be able to select the TLVs. Now, if I were to come in here, and let's take a look, I don't think there's many options for that. No, actually there's more than I thought there were. So we operate using, see, system TLV name. We can specify all of these criteria to be able to exchange. Oh, this is using LLDP. That's why. But when we start looking at it, how do I turn it on? Well, it's quite simply LLDP run. Now, if I come up here and do show LLDP, now we're going to see the information associated with LLDP. 30 seconds. We're advertising every 120 seconds. LLDP interface reinitialization delay is 2 seconds. So in the event that I lose this, I will attempt to resynchronize my link and my connection. Now, are we going to rely heavily on UDLD? No, but it is on the blueprint. It's in one of the first check boxes that we have to go through, so I wanted to make absolutely certain that we covered it. All right? So as we step in and start looking at it, CDP is going to be our go-to tool of choice to the extent that I'm going to go ahead and say no LLDP run and disable it. Because what I want to do is I want to be working with CDP. So do show CDP. Let's see if we have everybody up and working now. neighbors. And we should be good to go. So now we've got those double connections. So what I'm going to do is I'm going to bring the drawing back. So we see that Cat 1 is connected to Cat 4. We have 2 connections and a third connection going over to Cat 2. Those numbers are going to be gigabit 01. That's this connection here. That's connected to gigabit 01 on the other end. We have, let's see, to 2, 23 and 24. And we have the 2 connections going down to Cat 3, which are going to be 21 and 22. We can see that they're connected to 21 and 22 on both ends. Now, as you can see, quite quickly, we can go through and we can do all of these interconnections such that we now have an idea of how our devices are going to be interconnected, and this is what we're going to discover. It's going to be a reproduction of all of the numbers that we had before, 21 and 22. It will be 23 and 24, and obviously we're going to have this gigabit Ethernet connection that we have running across the top. So that allows us to be able to do things as simple as discovery. But now what we also want to realize is the fact that we're going to have interconnections to other devices. Now, the interconnection to other devices are going to be in the form of routers. Now, I'm going to pick a router to use for the illustrations because we need to talk about some special technologies and how we're going to be doing our interconnections. But first, before we go into this, what I want to do is in the current state of operation that we have right now, recognizing that we have 3560s, do we have any layer 2 interconnectivity between these devices whatsoever? So between Cat 1, Cat 2, Cat 3, and Cat 4, do I have a unified fabric in any way between these devices? Yes or no? Yes. Anybody else? You guys are on the ball. The VLAN, Avery's already said it. VLAN 1 is up and operational between all of these devices by default. So in other words, I have a single fabric connecting all of these switches, but I have no trunks. So what happens if I come in here and I create, let's go ahead and change pin colors. What happens if I come in here and create VLAN 10 and VLAN 20 on this device and this device, and I just create the VLAN? What's going to happen? What's going to be the outcome? While you guys are chiming in on that, I'm going to go ahead and go in and just do it. So on Cat 1 and Cat 2, I want to create VLAN 10 and 20. Sorry. VLAN 10, VLAN 20, exit. All right? So I cut over to Cat 2, VLAN 10, VLAN 20, exit. All right? Now, when I come up, the exact outcome here is will I have a trunk? All right? So if I come in here, what happens if I go over to Cat, I keep trying to use term server. If I type show VLAN brief, and I go through this, the question is, and I'm going to go ahead and take the drawing off just temporarily. In fact, I'll erase this since it's just all, I'm using an overlay on top of an overlay so that we can move quickly. So here's the situation. Notice I have VLAN 10 and VLAN 20 created. Notice it says active, but are they participating on any interfaces? Now I'm seeing a lot of information here, a lot of questions, a lot of statements, and some of it seem to be hit or miss. And like I said, what we need to do is we need to recognize what our operational parameters are, and we need to have a level of expectation before we do anything. So the moment I take two 3560s and I connect them together via crossover cable, do I get a trunk or do I not get a trunk? That's the question. Now I can look at this output and I can tell you immediately I don't have a trunk. Because if I had a trunk, these would be active, and when we're doing the connection, I haven't assigned them to any interfaces. So the question is if we're trunking, that means I'm going to have the ability to move VLANs, which means I'm going to have an instance of spanning tree. Right? And Jeffrey's got it. He's got, no, the ports are in desirable DTP mode, so no trunk. That's not a whole answer, Jeffrey. That's not a whole answer. Yes, I have absolutely no, I mean, if they're desirable, What mode are they in? Let's take a look at that. And let's see if I can't divine that answer here. So what we'll do is I'm going to type show interface FAO, let's just pick one, 23, switch port. And let's look at the parameters of this particular device. And what are we going to see here? Notice it's not in desirable, it's in dynamic auto. Now, I used to hang out with a lot of Marines and a lot of Army guys, Special Forces and all those people. And what you're going to realize immediately is that when you take two devices and you start interconnecting them, Cisco devices, and you're doing it, it depends on the model of device that you have. When we had 3550s, they had an operational mode of dynamic desirable. Now, the dynamic desirable, the dynamic part means I want to trunk. All right, the desirable part means I'm willing to go out and initiate the trunking process. 3560s have a base operational parameter of dynamic auto. Dynamic means they want to trunk, but they're not going to initiate it. They're going to wait. So they're going to automatically wait for someone else to initiate the trunk. So the thing is that, you know, traveling with the Marines, I mean, you walk into a bar, and, you know, one of them walks up to somebody else and says, hey, want a trunk? Well, the whole idea here is that desirable component is the amount of alcohol that it takes to get you to the point to where you're willing to ask. But everybody wants to trunk, right? Especially switches. So when we start looking at this, the main idea here is that when we start implementing the devices, they're not necessarily going to go into fruition. Now, Avery's asking, is that iOS dependent or is that hardware specific? Well, I can have the same version of iOS running on a 3550 and a 3560, and they're going to have basic operational variances. One's going to be dynamic desirable, one's going to be dynamic auto. So the answer to your question is it's going to be hardware specific. The 3560 that we have in our labs are going to be operating using this particular mode. All right? Now, as William's saying, note some of my switches are already configured for trunks and have separate VTP domains. That means that we got carryover config. So right now, don't worry about it. We're just going to some exploration. I'm going to get us to the point to where at the end of the day, I'm going to log out, I'm going to erase everybody's config, and I'm going to verify the revert script. My fear is that there's something in the revert script that's telling it to reinstall the old iOS. That's what I'm afraid of. So right now, let's just play around with what we've got. Let's explore. You know, we're going to do some Polish mine detection. You know, no insult required or intended. But the whole thing is we're just going to take a look at how everything's configured. All right. So don't concern yourselves. As long as you can get into the gear and you can look at the show commands, I just want you to get comfortable with moving around. And what's going to happen is once we get everything going, it's going to be quite literally Mach 1. We're going to be hitting the technologies. We're going to go through. I'm going to assign you tasks, and you're going to be doing things. In fact, tomorrow we'll probably start with a layer 2 lab. All right. Now, looking at this, not only do we have the dynamic auto configuration, notice my operational mode is static access. Now, the question is DTP. What does DTP stand for? Stands for Dynamic Trunking Protocol. Now what you need to understand is that each of these ports, in order for them to be dynamic, guess what? They have to have DTP on. So the moment I come in and I disable DTP, I'm not going to be able to negotiate. And I remember back in the day on group study, everybody arguing and whining and complaining about the best and easiest way in order to be able to get rid of DTP. Well, turn the crap off. If you turn it off, it's not going to be able to negotiate a link. And that's some of the things that we want to be able to entertain here. Because as CCIEs, we absolutely have to be able to look at a configuration and make a determination as to whether or not something's going to be operational or not. Now, the question here, the statement here has been put forth by William. So, do we change this to dynamic desirable? All right? Or do we use switch port no negotiate? Well, we could turn these features off. The fastest and easiest way to turn off the idea of DTP is to hardwire a switch to operate as an access port. All right. Now we have different types of ports. We've got access ports, we've got trunk ports. We'll talk about voice ports, and we'll talk about auxiliary VLAN ports and things like that later. I'm not really going to focus on that up front, but we will look at them when we start looking at some of our security and services capabilities. But right now the main focus is the fact that we can, to turn it off, we have a number of options. Now some of them are pretty critical. The suggestion's been put here by Pablo. Shut it down. Doggone right. Shutdown is probably one of the most powerful protection tools that you have in and apart from any security protocol that we may opt to run or decide to play with. So you may say it jokingly, but it does actually come into play. The aux port and excuse me, the aux port or the switch port, William's saying he thought that the auxiliary port or the auxiliary VLAN and the switch port voice had been killed. It just depends on what particular devices that you're working with. In 15 code, what we're going to find is we're going to have different terminology. It's still going to be pretty much the same thing. Cisco's got a bad habit of changing what they call something and pretending that it's brand new, I guess, so that they can actually turn around and sell it. But yes, the auxiliary VLAN is pretty much toast. I'll give you that. Got to remember, I have a tendency to bounce back pretty much to old school. But when we start looking at how these are connected, notice that the devices says the DTP mode is on. I'm in VLAN, which is my default VLAN. So every switch that we get is going to come in VLAN, and every interface on that switch is going to be participating in VLAN 1. Now, when we go through, there's some additional information that I want to go over later. But right now, what I want to do is I want to play around with this idea of dynamic auto. Now, the statement was made, how about we switch it to dynamic desirable? Let's do exactly that. In fact, what we're going to do is we're going to go overboard, and I'm going to take every interface that is an inter-switch link, except for the gigabit interface, and I'm going to enable it on Cat 1. And I'm going to tell it that I want you to operate in a mode that's going to try to elicit a trunk, and that's going to be the dynamic desirable. Because I've got auto on the other side, it's going to negotiate. So let's go through and take a look at that. So config T, interface FAO 19.224, interface range. Like I said, NXOS has killed me. Don't have to use the range command in NXOS either. So when you study data center, you'll understand what I'm talking about. What I'm going to do is I'm going to say switch port, mode, and let's look at our options. Well, we have access, .1Q tunnel, not part of the exam, dynamic, that is part of the exam, private VLAN, and trunk, so I could hardwire it. So let's take a look at this. So what we'll do is we'll say switch port, mode, dynamic, and my only other option between auto is going to be desirable. Now desirable is not going to actually go out and attempt to form a trunk. So we'll say desirable, press enter. Doesn't take long. So what we're going to do here is show interface trunk. Now notice it brought the interfaces down and then brought them back up. It brought them down and brought them back up because we have a change in mode. So before I even do that, I'm going to say switch port interface, fast Ethernet 19. I'm going to say switch port, but I'm going to come over here and say do first. And now what we're going to see is notice the change. Dynamic desirable, trunk negotiation is on, but here's the issue. Notice right here, it says ISL. There are two types of encapsulation. In the confines of version 5, we do not have to concern ourselves with ISL. We're only going to be concerned with .1Q. Now, .1Q is, again, industry standards. So it's a standards body protocol. ISL was a Cisco proprietary protocol that was originally designed such that we can be able to, they tried to beat the industry to market. And when we start talking about spanning tree, we're going to start talking about the war that went on between Cisco and the rest of the providers in the free world over this concept of virtual local area networks. But never lose sight of the fact that ISL, integrated switch links, are Cisco proprietary. We're not going to spend any more time talking about them because we don't need to know them in the context of the lab. So now what I want to do is I want to illustrate something. I want to illustrate the fact that we now have trunks. And the fastest and easiest way for me to prove that is to type the do show interface trunk command. Now, I'm going to go ahead and clear this output. Now notice it says ISL. What's that N stand for? It stands for negotiated. It was generated and configured to work with our DTP. Now, here's the interesting component. Let's go back over to Cat 2, and let's see if we can't play with some stuff. Notice 23 and 24 are the only interfaces that have links. I can demonstrate that by doing, again, the do show interface trunk command. I only have a trunk going to Cat 1. So, just in a nutshell, what do we have? We have this. We have Cat 1 connected to Cat 2 via two links. That's going to be 23 and 24 on both sides. And we are trunking. Now the problem is we're trunking ISL. And that's a default of this particular device itself. So when we look at this, how do I change it? Well, we used the idea of DTP. So we got dynamic trunking protocol configured here. All right. So if I were to take a look at the trunk on this line, notice it says in ISL. Well, that's interesting. So let's take a look at this interface right here. Let's go to Fast Ethernet 13, interface FAO, I'm sorry, 23. And I want to change this behavior. I still want to use DTP, but I don't want to play with Cat1 using ISL. So what I'm going to end up doing here is I'm going to come over here and I'm going to say I want to change my encapsulation method. So I'm going to say switch port mode, I'm sorry, switch port trunk encapsulation, and I'm going to say .1Q. Notice it's negotiate by default. It's going to negotiate ISL first by configuration, but I want to change it to .1Q. I want to use that industry standard protocol. Now when we take a look at this, do show interface trunk, do show interface trunk. Let's see what we see here. Well, we had a change in behavior. It's not ISL anymore, but something else disappeared. The thing that disappeared was, where's that in? Where'd that in go? I mean, are we not using DTP anymore? So the question is, how do I know what I'm doing? Well, again, we're going to use that show interface FAO23 switch port command. All right, so I'm going to go ahead and erase this scroll right here. And let's take a look and see what we have. So when I look at this, I need to, I didn't want to do that. Edit, undo. Should let me undo. There we go. Should have 3 levels of undo. So when we look at this, notice I have dynamic auto, but we are in a trunk mode. Now notice it says administrative trunking encapsulation .1Q. Anytime you see administrative, that means I configured it. All right? So what is our operational mode? Well, our operational mode is .1Q, and we are still running negotiating of trunking. So DTP is still on by default in this particular configuration. Now the question is what does it look like on the other end? Let's go back over to Cat1 and execute the show interface trunk command. Notice it still says ISL, and it still says in. Now it says in because what happened was this. Cat1 is configured such that it wants to form a trunk. We made it desirable, so it's going to go so far as to initiate it. It is hardwired to attempt to create an ISL trunk first. So it's going to say, psst, Cat2, let's trunk. All right, I want to use ISL. Cat2 looks at all those messages and says, well, got a problem. I want to trunk, but I don't want to use ISL. I've been hardwired, administratively configured to run .1Q. So what happens at that particular juncture is it's going to send a renegotiation request. The renegotiation request is going to come across. DTP is going to say, oh, well, we have a compatibilities table. You are not compatible with ISL based on configuration. .1Q is the next available option. You say that you have that parameter, so let's turn the trunk up and become operational. Now, what we see here is William saying that's why why one side says 802.1Q and the other side says in 802.1Q. Exactly. So as we start looking at how this is going to be interconfigured or interconnected, we now have the negotiated 802.1Q. Again, do nothing in the confines of anything you ever do in technology unless you know what's going to happen and why. These devices are communicating. They're exchanging information. They're exchanging control information between each other in VLAN 1. So all of the associated information, all of this negotiation that's taking place for every VLAN that we have, and we've only got 3, we've got 1, we've got 10, and we've got 20 in the current configuration, but all of that information is taking place across VLAN 1, which is why we can't delete it. There's no way that the system is going to allow me to come in here and say, config T, no VLAN 1. It's just simply not going to call the command. It's going to tell me to piss off. You can't delete it. Why? Because it's control plane configuration. All right, now we have the native VLAN. Well, William's saying the native VLAN is also needed to establish the trunk. Again, exactly. All of the control plane information, all of the negotiation, physical and for our layer 2 protocols to include our VLANs and our spanning tree configurations all require VLAN 1 to operate. Now we can do VLAN 1 minimization. whereby what we can do is we can pick a new native VLAN and we can move stuff around, and we can use that instead of VLAN 1, and that's going to be more security than anything else. But understand the fact that we can do it. Another option here is that what we have to recognize is that whatever our VLAN, native VLAN is, and by default it's going to be 1, in the context of .1Q, .1Q is not going to encapsulate the native VLAN. So there's no encapsulation on it. So there's no headers. There's no actual 802.1p bits that have been assigned to that particular piece of information, so there's no tagging. There's no information associated with it. It's just accepted as fact that if I receive a packet, or a frame, excuse me, that's not tagged, I'm going to look at my native VLAN and say, oh, this is VLAN 1, so that's what I'm going to treat it as. I'm going to treat it as VLAN 1. Because until such time that I say to tag native VLAN traffic, there's no way for us to be able to verify that. All right? Now the problem is that we end up with a situation where if the native VLAN over here is 10 and the native VLAN over on Cat 1 is 20, we are going to be able to do something called VLAN hopping. Now in other words, I'm going to receive a packet that's 10, I'm going to look at it and say, oh, it doesn't have a header, I'm going to put it into 20 and send it on its merry way in VLAN 20. That's not a good thing. Now what we have to recognize is we have another tool available to us that's going to prevent us from entering situations where that's going to be catastrophic. And that's the one that we've already talked about, CDP. Cisco Discovery Protocol is also running on that trunk in what VLAN? VLAN 1. So what's going to end up happening is VLAN 1, the CDP information, remember one of the outputs, if I come over here and I type do show CDP and I hit enter, I don't get anything, but if I do that detail, need to be, is it interface? No, neighbor. I can't complete. Show CDP, interface, FAO23, nope, it'll be neighbor. Neighbor, show CDP neighbor, detail. I should be able to restrict this further. I think it's out FAO23 detail. I don't want to look at all of them. There we go. All right, notice it says here, native VLAN. CDP knows who the native VLAN is. So by virtue of the fact that CDP don't match on either end, the system is going to say, Terry, don't do this. There's going to be a message. It's going to say native VLAN mismatch, native VLAN mismatch, native VLAN mismatch. It's not going to shut the ports down on this particular device, but on some units it will. In the context of the lab, it won't, but you're going to constantly get that scrolling message that's going to let us know that we have problems. So we're not going to get bit in the butt. So keep in mind, CDP protocol is not just for neighbor discovery. CDP protocol is going to be one of the most critical and integral components that we have for the creation of link-by-link, hardware-to-hardware communication associated with layer 2 adjacency that we have in all of our tool bags. So it's definitely not something that we want to be able to ignore. All right. Now, John's saying management traffic passes through the native VLAN. Yeah, okay, yes. Management traffic definitely passes through that particular, that's going to include the native VLAN, which is going to cover DTP, CDP, LLDP if we're running it, and any other protocol that's going to impact operation. To include UDLD, unidirectional link detection. So keep in mind what we're talking about here. We've got all of these tools associated with CDP, and it even comes into play into higher functions like making certain that our individual devices operate and do what we want them to. Now, let's address this point right now. So when we came in here, we had VLAN 10 and VLAN 20. We created them. So when I come up here and I type show VLAN brief, notice I don't see anything here to tell me anything about this. I've got active VLAN, and that's all I see. I don't see any physically assigned interfaces. But the other thing that I want to point out is notice out of my interface list, do we see 19, 20, 21, 22, 23, 24? We don't. Notice we see gigabit 01, and we said gigabit 01 was connected across that link. Well, guess what? It's not running a trunk. Those interfaces aren't missing. Those interfaces are operating as trunks. So if I come in here and type show interface trunk and hit enter, what we're going to see is here's the missing interfaces. I'll go ahead and move this out of the way again. Those are the missing interfaces. So they're not gone. But what I want to point out here is notice that it tells me VLAN 1 is my native VLAN, tells me that I'm trunking, gives me all the information that we were working on. So now what I want to do, since we're going to stay inside the confines of the RNS version 5 routing exam, I'm going to go ahead and set this up to where every one of these links are going to be .1Q. I don't care if they're negotiating or not, I just want to make sure that they're going to be .1Q. So all I'll do is I'll come in here and say config T, interface range, FA0 19 to 24. I'm going to say switch port, trunk, encapsulation, .1Q, exit, exit, show, interface, trunk. And by the time it comes back up, everything's going to be .1Q. Now obviously on the other ends, it's going to be .1Q negotiated. So let's take a look at that. Let's cut over to Cat2. Show interface trunk. Well, I said everything was going to be in. Well, notice I only have 802.1Q. Well, remember, we hardwired that for 802.1Q as the encapsulation protocol. But we're still running NTP. I'm sorry, we're still running DTP. Show interface FAO 23 switch port. And what do we see? We see negotiation of trunking is turned on. The negotiation of the trunking doesn't have anything to do with the encapsulation protocol. The encapsulation protocol is just part of the overall negotiation. So the question is, what happens if I come over here to Fast Ethernet 23? All right, let's draw that out real quick. We got Cat 1, we got Cat 2. Connected, 23, 24, 23, and 24. All right. Now, on this link, on 23, notice we're hardwired to use .1Q. Down here, we're using negotiated .1Q. Now, we mentioned, in fact, I can't remember who it was, I think it was William, was talking about switch port, no, negotiate. One way to turn off DTP. So on this link right here, on this in link, let's go to port 24 and let's disable that negotiation methodology. So all I do is config T, interface FAO 24, switch port, no, negotiate. Now here's the issue. I mean, at first thought is well, if you turn off no negotiate, this should bring those links down. Well, it's going to bring the links down, or it would, but the problem is notice that we have a conflict between the no negotiate and the dynamic state. The dynamic state says use or rely on DTP. If I turn DTP off, I can't do dynamic. So iOS is going to recognize the conundrum and it's going to forbid me from making those changes. Let's do the same thing on Fast Ethernet 23. Switch port, no, negotiate. Notice here it says conflict between no negotiate and dynamic status. Think about that. I mean, when you first do this command here, show interface trunk, do show interface trunk, you see this, and the first thing you think is that you're not using trunking. Well, guess what? You are. That's what this mode is. We're using auto. So unless I take the port out of auto configuration, I can't turn off DTP. So the only other real option that I have is to shut it down. I could come in and hardwire it, and that's exactly what John's suggesting right here. So encapsulation needs to be defined before I can actually change it. All right, well, okay, the question is it's like Manuel's saying, encapsulation needs to be defined for me to change it. Well, let's take a look at our configs here. Let's make sure I'm not messing something up. Show, do show, interface, FAO 19, and I'm not 19, 23 and 24. Well, notice I have switch port trunk encapsulation, so my encapsulation's set, but I want to be able to force my trunking. So let's do that. So let's make sure we're on the right interface. So interface FAO 23, and I'm going to say switch port mode trunk. Now I've hardwired it. Now let's see what happens. Show interface trunk. And let's see what we've got going on here. So now notice, I'll go ahead and clear this off. I'll erase it. Now notice that we have on. and we have 802.1q on port 23, which we know 23 from Cat 2 goes all the way to 23 on Cat 1, right? So my mode is now on. So I'm not running DTP. How do I know that? Well, let's double check it. Let's come up here and say do show excuse me, interface FAO23 switch port. And what do we see? Administrative mode trunk, operational mode trunk. The administrative mode and the operational mode can be completely different. The administrative mode could say it's administratively configured to operate as X, but I could actually be access because I failed to negotiate anything. But the main thing I want you to understand is keep in mind here, do show interface trunk tells me that this bad bear is operating in mode on, and I have an 802.1q trunk to my neighbor. I even see that. I mean, that's telling me the information. Let's cut over to Cat 1. Show interface trunk. So let's see here. We've got 23 and 24. Those are the two links that we have. We're .1q. We're trunking. Everything looks to be good to go. Now, how can I test this? Well, we can test this with the concept of an SVI, switch virtual interface. So what I would do is I would come over here on Cat 1 and I would create an interface. I almost typed feature interface VLAN. So what I would do is I'd say interface VLAN. Let's create a management interface in VLAN 1. Let's just say it's IP address 10.10.0.1.255.255.255.0. No shut. Let's cut over to Cat 2, do the same thing. Interface VLAN 1 IP address 10.10.0.2. Actually, I didn't want to do that, but no big deal. I like using the router numbers, so I'm going to actually modify that. So I'm going to say 7 for Cat 1, since it's after, and then I'll say 8 for Cat 2. All right, so now, no shut. So let's see, can I ping 10.10.0.7? And I'm able to ping. It's no problem. So what I'm actually doing here is I'm taking my SVI interfaces that I just created. So I have SVI 1, SVI 1, did 10.10.0.7 and 10.10.0.8, and I'm now able to ping because I'm pinging across this trunk. Hold on one second. Say best practice mode on switch port mode no negotiate. Okay, basically to turn it off. Now, what we've got going on here, let's take a look and see what's exactly happening. So I just wanted to demonstrate that I have reachability because we're going to be using these SVIs for reachability and testing and stuff like that later. But right now, show interface FAO23 switch port. Let's take a look and see what we have. I'm going to go ahead and just erase this stuff so it's not in our way. Okay. Notice here that my negotiation of trunking is still on. So in order for me to be able to change this, or do I even need to change it? I mean, it just depends what my outcome is. Show run interface FAO23. Show run interface 24. So what we have here is switch port trunk encapsulation, but notice I'm still running in dynamic desirable. Here I'm still running in dynamic desirable. Well, what would happen if I turned this into a trunk? Show run, well, no, we'll do this. First, I'm going to show run interface FAO23. So here, notice we're hardwired, switch port mode trunk, switch port trunk encapsulation .1q, so switch port interface FAO23. That's not what I wanted to do. Switch port. Okay. Negotiation of trunking is still on. So what do we change? Anything? Show run interface FAO23. Our mode trunk. So does changing it to trunk get rid of DTP? No. The only way that I can turn off DTP is to shut the interface down, change it to an access port, or to configure no switch port negotiate. So let's do that. So what I'm going to do is I'm going to come in here, config T, interface FAO23 and say no, or switch port, no negotiate. Do show interface trunk. Now before I hit enter, what's going to happen? Anybody have an idea? What's going to happen to the link between 23, between Cat 1 and Cat 2? Will I have a trunk? Will I not have a trunk? Anybody venture a guess? Trunk will go down. Yes, we'll have a trunk. Well, we still have a trunk. Look at it. What does it say here? It says on 802.1q trunking native. Now the question is what's happening on Cat 1? Let's take a look at it. Show interface trunk. Now here we got an issue going on here. I mean, if I were to just, let me go ahead and just clear this part of the output right here. I mean, if I were to look at this, first thing I would think is that I would have a trunk. Because notice right here it says desirable 802.1q and it tells me that I'm trunking. So the question is if I turned off 2024, because that's the only working link that I have right now to this device. So what I'm going to do is I'm going to actually come in here and I'm going to shut down port 24. Shut. Okay, now it's down. So let's take a look at this. Show interface FAO 23 switch port. Do. All right, I'm going to get rid of all this garbage. So what do we see here? We've got dynamic desirable still. We have trunk .1q on .1q. Now, so far it's been postulated by a number of you guys that says it's up because it's already negotiated. Well, the question is it actually up? Can we ping now? Ping 10, 0, 8. Well, we still have reachability. So if I turn it off and bring it back on, will it negotiate? You think? Config T, interface, FAO 23, shut. Do show interface trunk. Okay, do we see 23 and 24 in this mix anywhere now? No. So let's bring it back up and see if it negotiates. Just satisfy everybody's curiosity. Show no shutdown. Okay, show interface trunk. Show, do show. Okay, now we got something going on here. Look here, notice it says, received a 1Q non-trunk message via spanning tree. We received an 802.1q BPDU on trunk fast Ethernet 023 for VLAN 1. And notice it went to an inconsistent port type. We're blocking on this port. So let's take a look and see what's going on now. Show interface trunk. What do we see? Do we see 23 and 24? Nope. Show spanning tree. Now we haven't talked about spanning tree, but I'm going to go ahead and do it. I'm going to say show spanning tree. Do show spanning tree. Show spanning tree for VLAN 1. Well, notice we don't even have anything going on here. We got 23 designated. We've got 22. But what 24 is turned off. Well, in this scenario, notice 23 says it's forwarding. It's trying to send information across that link. Let's cut over to Cat 2 and see what's happening. Notice we didn't get any messages on this side. Exit. Exit. Show interface trunk. Well, here notice this says we're trunking. 23 is telling me we're trunking. So why would a show command on Cat 2 say that I'm trunking when I look at Cat 1 and I see my output here on 23, show interface trunk. Let's see what we see. Trunk. I don't even have 23 and 24 up and operational in my list. So what's the issue here? What's happening? It's because Cat2 is hard-coded. William's suggesting. Anybody else got any input? It boils down to the significance of the show commands. When I come over to a device, let's say we have in our topology, we have Cat2, Cat1 and Cat2, excuse me. Now we've been talking about, we played havoc with this poor link. I mean, you're not going to have to worry about too much of stuff with associated to it, but the main idea was we have fast Ethernet 023 on both ends. And I'm executing a show command. The whole object of this exercise is to not demonstrate what combination of values indicate a successful trunk. It's to show you that show commands can be misleading. Because when I execute a show command on Cat1, it's giving me the information from Cat1's point of view. So the link that's between these two devices, FAO23, it's only telling me specifically about this end of the link. Now this end of the link is not up and operational because its modes have failed. We have a mismatch between the configurations that's preventing us from being able to bring 23 up and operational. Now, up and operational, that's what I want to beg the difference. Up is the state. That's what the show command is actually illustrating to us. It's not giving us the information as to whether or not the information or the port or the link is actually operating. The show command only gives us our administrative state and our operational state when the operational state is linked to the administrative state, like it is in the context of like serial connections and things like that. But it's not telling us this trunk is actually up and operational. So when we start looking at this, the show command on Cat2 says it's up, the show command on Cat1 says it's down, but the reason being is that it has no negotiation protocol on this end, so it can't be any other state but up. Whether it's operational or not, the trunk interface ports on that device thinks that everything's operational. So the problem is what I want to make you understand is that if you execute a show command to see the status of a link, you darn well better do it on both ends of the link. Because both ends of the link are going to allow us to make certain that we can bring up our links. So if we were to look at this from the point of view of just putting it into a table, what we see here is that we're going to have the table, and what we'll end up having here is our modes. So my first mode would be on and on, which means I'm going to be able to form a trunk. If I have desirable and I have on, I'm not going to form a trunk. If I have desirable and desirable, I am going to form a trunk. If I have desirable and auto, I'm going to form a trunk. So if I have auto and on, I'm not going to form a trunk. If I have auto and desirable, I'm going to form a trunk. And if I have auto and auto, I am not going to form a trunk. They'll be willing, but no one's willing to initiate the process. So on and desirable, no trunk. So rather than illustrate each and every one of those individual possibilities, what we can do is you guys can lab it at your leisure. But the main point here is that this is our trunking. This is for trunks. And what I was trying to drive home is the point that our encapsulation is part of the trunking negotiation. But when we want to turn off trunking, DTP, Dynamic Trunking Protocol, the only options that we have are the no negotiate and access. Because when I set up trunk, remember we went in and typed mode trunk, it didn't turn off DTP. So let's just look at that real quick, and then what we'll do is we're going to move forward on some of the other topics. So when we step in here, show interface status, or excuse me, show run interface FAO23, what we're going to find here is that we have switch port trunk encapsulation.1Q. We have switch port mode desirable, so DTP is automatically running. So what I'm going to do is I'm going to come in here and change that mode. So config T. I'm going to say interface FAO23. I'm going to say switch port mode trunk, but it's not going to let me enter the command. Well, yeah, it will, because I've already done the encapsulation. If I didn't do the encapsulation, it wouldn't let me do it. Now show interface trunk. Let's see what's going on. And now notice 23 is now up and operational on this end. And let me see if I can ping VLAN 1. 10, 10, 0, 8. And I have reachability. Now, looking at how all of this goes in, I've demonstrated SVI interfaces. I've demonstrated our alternate trunking modes. I've talked about DTP. I've talked about the significance of DTP and how to turn it off. The only thing I haven't illustrated is how to actually turn it off with a single command, and that's going to be through the switch port no negotiate we've talked about. But one of the other options, and I'll just illustrate it just for custom's sake, is to go to interface FAO 24 and say switch port mode access. Do show interface FAO 24 switch port, and what we're going to see now is DTP has been turned off. Why? Because we're operating in an access state. And VLAN 1 is going to be our default VLAN for that configuration. So, I mean, that's pretty much the concept of trunks in a nutshell. But what we need to recognize here is that it really boils down to just a few things. When it comes to our modes, our port modes, we have access port, we have trunk ports, and we have VLANs. Now we also have this concept of an SVI, a switched virtual interface. And a switched virtual interface is very important to us because it allows us to obtain a way of being able to test these links. Now when it comes to an access port is one VLAN. A trunk port is going to be all VLANs. All VLANs by default. All VLANs by default will be allowed on a trunk. We can go in and we obviously can manipulate that to ensure that that process isn't going to take place. And what I want to do is I want to review that right now. So if I come back over to our gear, what we're going to do is we're going to create some more SVIs. I want to create an SVI for 10 and an SVI for 20. So when we go in, on this side it will be interface VLAN 10, IP address 10, 10, 10, 7/24. And I'm going to say interface VLAN 20, IP address 10, 10, 20, 7/24. Whoops. No shut. Let's go over to Cat 2 and do the same thing. 10, 10, 10, 10, 8/24. Interface VLAN 20, IP address 10, 10, 20, 8. No shut. Show interface trunk. We got 23. That's the only trunk that we're using to operate. All I want to do is make sure that we can ping 10, 10, 10, 7. And 10, 10, 10, 20, or 10, 10, 20, 7. And we should have reachability across the board. Now, this is all made possible by virtue of the fact that our trunk, show interface trunk, by default, is going to be running all three of our VLANs. VLANs allowed and active in the management domain. All VLANs allowed on the trunk, 1 through 4094. Whether we've created them there or not, by default they're going to be there. So what I wanted to do is just simply going to entertain the possibility and the tools that we have available to us to be able to filter this without talking about VTP. First and foremost, when we come up and we set the system up, what we recognize is the fact that we have the ability to control this link. So show, or do show, run interface FAO 23. Now what happens if I want to keep a VLAN off of this link? Well, all I do is I go to the interface and I say switch port trunk allowed VLAN, and it gives me the capability of specifying a list of VLANs that I'm going to be allowed, or I can actually remove them, because remember, by default all of them are actually allowed. So if I come up here and say VLAN except 20 or 10 on this side, what I really need to make certain that I do is I actually match it on both sides of the equation. So I'll come up here and say do show history. Take a look at that output. I'm just going to grab it. I'm going to come over here to Cat 2. I'm going to say en config t, control paste, and I just put the configuration in there. So now if I come across, I want to ping 10, VLAN 1. If I want to ping 10.10.0.7, if I type it right, it should work. And if I want to ping 20, now let's look at the VLAN that we filtered. VLAN 10. We don't have reachability. Configuration needs to match on both ends of the link when we make this type of configuration. Now another thing that we really need to entertain here is the concept of being able to manage these VLANs. Because what I want to illustrate here is that notice that if I come over to SW1, take a look at this, show, exit, show interface trunk, what we're going to see is that I have connectivity to different devices. I have connectivity 23, I've got 19 and 20 and 20 and 21. So if we come up here and do show CDP neighbors, we're going to find out what's connected to what. And then I'll get to the question. Jeffrey's saying, does the native VLAN have to be explicitly allowed on the trunk? Does the native VLAN have to be explicitly allowed on the trunk? The native VLAN has to be on the trunk. We can do VLAN minimization, but if you don't have the native VLAN allowed on the trunk, you're going to be trashing your config. So let's go through here and let's take a look at that. So what would happen, config T, interface FAO 23, that's the link that we have that's running, and I'm going to say switch port trunk allowed remove, or VLAN, remove 1. Do the same thing on the other side. Control. Config T, interface FAO 23, switch port trunk allowed VLAN remove 1. Now what we've just done is called VLAN minimization. Is the native VLAN, it's the native VLAN no tagging. The native VLAN shouldn't be tagged. It's not by default. But, oh, I'm sorry, does the native VLAN have to be explicitly allowed on the trunk? That's the question I'm trying to answer right now. So what we have is we've done VLAN minimization. So when I come up here and I type ping 10, see 10.10.20 or 10.7. Let me make sure I'm on the right device. Well, that's VLAN 10. No go. See what happens when we ping 20. Can we reach it? Okay, that one's working. What happens when we ping VLAN 1? Now, why do we call this VLAN minimization? Anybody have an idea? I'll go ahead and draw it out while you guys are thinking. We have Cat 1 and we have Cat 2. Zero 23, 023. Well, what we did is we first of all had 1 to 4,094 VLANs that were allowed on the link. Then we went down and said that we wanted to support 1, 10, and 20, simply because those are the VLANs that are configured. Those are the VLANs that are in the VLAN database. And what we did is we removed 10 and 1 from the list. Now, you would think if VLAN 1 is part of my control plane traffic, that I would shut my link down. So for instance, if I can't negotiate my link, if I come in here right now and shut this port down, will it come back up? Let's take a look at that. I mean, these are all questions that we need to be able to answer, ask ourselves, and find definitive answers for. So if I come in here and say config T interface FAO23 and shut this interface down, if I bring it back up, will it come back up? Jeffrey's saying, I mean, if you are restricting VLANs allowed, do you have to include the native VLAN regardless? It's best practice to include the native VLAN, but what I'm getting to illustrate here is we're killing the native VLAN for the purposes of forwarding traffic in this scenario, but it's still going to be operating for the purposes of our layer 2 mechanisms like CDP and stuff like that. So let's see, we'll bring it back up. No shut. Show interface trunk, do show. And 23's back up and operational. So when we come in here and we say do show CDP, neighbor, our connection between 1 and 2 is still up and operational. Still up and operational on 23. So it's called VLAN minimization or VLAN or native VLAN minimization simply because we're removing it for the purposes of data, but we're not taking it away with regard to being able and available for control plane mechanisms. Now, let's talk about why. Any of you guys familiar with a concept called pack priority? We've got 3 concepts I want to talk about right now, and I promise I'll give you guys a break. I know you're probably seeing yellow right now. All right? We have CDP. We've already talked about it. Well, you need to learn to write. CDP, Cisco Discovery Protocol. Cisco Discovery Protocol operates in VLAN 1 by default, but the best way to put it is it's going to operate in the native VLAN. And we can keep saying native VLAN because the only thing that we have to concern ourselves with is 802.1q. Trunks. We don't have ISLs anymore. Remember, Cisco proprietary, gone by the way of the dodo. All right, now when we come through here, there's another process that I want to spend some time talking about because we're talking about layer 2. We're talking about layer 2 technologies. So one of these concepts that we need to talk about is called CEF, excuse me. Cisco Express Forwarding. Guys, this is the best thing since sliced bread. Cisco Express Forwarding enables so many features. Can't run MPLS without it. The idea of process switching versus fast switching versus CEF, night and day. All right? Now what we have to realize here is that in version 5, routing and switching, we're going to skirt a topic. We're not going to spend a huge amount of time talking about it, but I really think that it's important that we actually represent this because I really don't want to fire up any routers right now. So I'm going to mention it now and then we're going to actually illustrate it later. CEF was built for hardware optimization. It was designed to operate in ASICs. ASIC stands for Application Specific Integrated Circuits. Now, layer 3 switching. Layer 3 switching with regard to CEF works a little bit differently, but we're still going to have to be able to deal with it because not only is it going to be layer 3 switching, we're also going to use it as an enhancement to expand on our capability of being able to send information across our infrastructure. Now we're going to be talking about, or we are talking about switches. Now, it should come as no surprise that a switch switches. Just as it should become as no surprise that routers route between segments. Switches, unified broadcast domain, routers break up broadcast domains and allow us to be able to move traffic from one Ethernet segment to another through the virtue of the fact that we can cross over and we can traverse VLANs, or we can traverse networks. Now, what a lot of people don't really think about is the fact that switches can also route. I can go in and enable IP routing on a layer 3 capable switch and it'll work perfectly fine. But the element that a lot of people don't think about is that routers switch. They switch, they use CEF. It's non-hardware optimized. There's no dedicated ASICs in the majority of the chassis that we're working with, even at ISR Generation 2 devices. But it's still a very, very significant component to sending information from point A to point B, and we have to recognize exactly what the capacity is for switching. So what I want to do is before we take our break, I want to look at the confines of sending information through our infrastructure using a router. Because a lot of people, especially nowadays inside the context of version 5, we don't have to worry about things about enabling bridging on routers. I'm going to make you do it because we're going to use routers to generate BPDUs so that we can test things like our BPDU guard features or look at what happens when we receive BPDUs in the context of our port channel our port fast configurations. But routers also switch. So if I have a router and it's interconnected, and like I said, I know we haven't talked about routers themselves, but what we have to recognize is that we have interfaces. Whether it's gigabit Ethernet interfaces or fast Ethernet interfaces, I'm going to take my head out of the way so I'm not part of the equation here. What we need to pay attention to is like I said, routers route. That's their primary job. But routers can't route until they switch. So let's imagine I have a packet. My packet arrives. Well, my packet has a source and a destination set of addresses. I have a source IP, I have a source port, I have a destination IP, I have a destination port. I also have layer 2 information. I have a source MAC address. I have a destination MAC address. Now, when we start looking at this, what ends up happening is that we're going to need some tables, and William's focusing on my idea here. And what we need to recognize is we have the RIB, the routing information base. When we have Ceph as part of the equation, we also receive something that's referred to as the forwarding information base that is also going to include something called the adjacency table. Now, I'm not going to talk about the optimization just yet. I just want to talk about the process. So what ends up happening is I have a source IP address and I have this destination address. Now what's going to happen is I'm going to require either static routes or I'm going to require IGPs, Interior Gateway Routing Protocols, to exchange information so that I can create my RIB, my routing information base. Think of it as a big, huge list of control plane information. Critical pieces of control plane information are going to actually be populated into the forwarding information base, which is going to be how we refer to our routing table. Now again, I know I'm putting the cart before the horse with regard to routing and switching. We're still talking about layer 2, but this is important. Because what's going to end up happening here is this packet, this is not a 0, it's a packet. It arrives and it's going to say I need to get to the IP address of 1.2.3.4. Now what's going to happen is this device is going to take this information and it's going to parse the routing information base. Or actually it's going to parse the FIB. We'll do it right. It's going to parse the forwarding information base. Now what's going to happen is that I need to know where to send this information. So let's imagine we've got another interface down here. So we've got FAO2. We got a funky router. All right, we got 3 interfaces on it. So what's going to end up happening is I'm going to parse my table. Parse. Some people call it walk the table. But I'm going to parse my FIB. Now what will happen is I can say 1, 2, 3, 4 is reachable via 5, 6, 7, 8. But that don't help me, because I'm trying to switch. In order to be able to switch, I need to send it to an interface for the purposes of encapsulation. So what's going to happen now is I'm going to have to parse my table again. This is a process known as recursion. So I may look up 5, 6, 7, and 8 and find out that 5, 6, 7, and 8 is reachable by 9, 0, 1, 2. Then I need to look up 9, 0, 1, 2 such that I can actually resolve that possibly it belongs to 3.4.5.6. And then ultimately what's going to happen is I want to parse this table such that I have, let's see, 5, 6, such that I come up with an interface, FAO1. Now the moment that I've recursed to an interface, what I'm going to do is I'm going to take this packet and I'm going to switch it from one interface buffer to another for the purposes of serializing it and sending it out on my link. So switching is a very, very integral part of routing, but it's also one of the reasons that our routers or these routing devices are finding fewer and fewer applications in infrastructure that's going to end up being involved in data centers, because routers work slow. They don't have hardware optimization. I mean, it's not like a Nexus with a fully populated backplane. Now, no, I'm being asked, is that the equivalent of the ARP table? No. We'll talk about exactly what's involved in this entire process that I've just revealed here. But it's going to be the creation of this idea of the adjacency table. The adjacency table is going to be very important because it's going to actually take information from multiple sources and it's going to be able to put it together. And the ARP table is not the MAC table. That's being suggested. Pablo is saying that the ARP table, the address resolution protocol table, is the actual MAC address table. The ARP table is the control plane mechanism used to create the MAC address table, or what's more accurately referred to as the CAM table, the Content Addressable Memory Table. In more modern device, we have what's referred to as a TCAM, which is a tertiary Content Addressable Memory Table. And we'll talk about the difference between these two shortly.